So we have solved linear systems of equations, and we have solved systems of three linear equations. Now we want to look at what happens when we have nonlinear systems. On each of these examples, I have already included a picture that shows the solution. And so if I were doing this for a homework assignment or for an assessment, I would certainly use the graph to check my work. But keep in mind, I will be looking for all of your work. So what's important to do, and hopefully you're really good at this by now, is, and again, if I didn't already know what my intersection looked like, I would look at my first equation and say that that is a quadratic equation. So this is going to be a parabola. And my second one is written in slope-intercept form, so obviously this is linear. Now, why would I start with that? Because I want to know, before I get started, what's the most number of times that these could cross? So a parabola with a line could cross 0 times, it could cross 1 time, or it could cross 2 times. So 2 is the most number of intersections I should have, 0 is the least. So how am I going to solve this system? Well, in this particular system, if you'll notice, I have y equals and y equals. So I'm going to choose to use substitution. And the reason that I'm using substitution is I can say, let's substitute all of this in for this y. So I'm going to have x squared plus 2x minus 8 equals 2x minus 8. So from here, I'm just going to solve, and this is a quadratic, and in order to solve a quadratic, I'm going to get everything to one side of the equation. So I'm going to subtract 2x from each side, and if you'll notice, something peculiar happens. That goes away. And then if I add 8 to each side, if you'll notice, something peculiar happens, and that goes away. So I actually just have x squared equals 0. And if I take the square root of each side of that, I don't have to worry about the plus or minus because the square root of 0 is 0. So 0 is the x value of my intercept. I need to find an ordered pair, which is the solution. So I have to take 0 and plug it back into either one of my original equations. So I'm going to choose to plug it into my second equation. Y equals 2 times 0 minus 8. Y equals 0 minus 8. Y equals negative 8. So my solution, always written as an ordered pair, is 0, negative 8. Again, I can then graph those on Desmos and find that that is in fact the one solution. If you'd like, you can try this one on your own, as it's very similar to the last question. But this obviously is, again, a parabola and a line. And that means up to 2 solutions, as few as 0. And again, you can cheat. I have already figured out there's going to be 2 solutions. But I suggest trying to do the math first. And the math in this case, again, I'm going to use substitution because they're both set up as y equals. So I'm going to take all of this and plug it in for y in the other equation. X squared minus 3x equals 2x minus 4. This is a quadratic because my largest degree is 2. So let's get everything to one side. Let's subtract 2x from each side. That gives me negative 5x. Let's add 4 to each side, because we always want it equal to 0. From here, I would then try to factor if possible. Are there numbers that multiply to 4 that add to negative 5? That would be negative 4 and negative 1 would multiply to positive 4, would add to negative 5. If I solve, I get x is positive 4, x is positive 1. But don't stop there because I'm looking for the solution, and the solution is always ordered pairs. Now, as you can see, based on my little cheat over here, notice the x value of one of my answers is 4 and the x value of one of my answers is 1. So I know I'm on the right track. So in order to find the y values, choose one of your two equations, plug in the 4. So y equals 2 times 4, which is 8 minus 4. So y is 4, which means when I plugged in 4, I got 4 back out. And then do the same for the other x value. Y equals 2 times 1 minus 4. So y equals 2 minus 4, y equals negative 2. So when I plugged in 1, negative 2 came out. So those are my two solutions to this nonlinear system. So this one's a little bit different than the last one because my very first equation is actually a circle, which hopefully you remember from one of our first couple of weeks of material. Our second one is still a line, but again, it's a good idea before you get started to think about the fact that a circle and a line could cross no times, or 1 time, or 2 times. So keep in mind that I should have no more than 2 solutions. To solve, I'm going to use substitution, and this one's going to get a little bit more complicated because if I isolate a variable, I'm going to isolate the x. So I'm going to add y to each side of this equation to get x equals 4 plus y. So what's going to happen is that I'm going to take my first equation, x squared plus y squared equals 16, and I'm going to replace x with 4 plus y. So I'm just going to keep solving this. It's going to be a quadratic, but keep in mind that 4 plus y squared is actually 4 plus y times 4 plus y, so that would require me to FOIL it. Hopefully you're really good at FOILing by now. 4 times 4 is 16. 4 times plus y is plus 4y. Y times plus 4 is plus 4y. Y times y is y squared. So that would be 16 plus 8y plus y squared, and that's going to go here. I still have this plus y squared, don't forget to include it, and of course I have equals 16. This is a quadratic because my highest degree is 2. So let's combine these guys, 2y squared. We have plus 8y plus 16 equals 16. Let's subtract 16 from each side because we want it to be equal to 0. And what happens is that other 16 cancels out. So I just have 2y squared plus 8y equals 0. If I want to factor that, I would take a 2y out of both of those, leaving me with y plus 4 equals 0. Then to find my solutions, I'm going to set 2y equal to 0 to find y is 0, and y plus 4 equal to 0 to find that y is negative 4. Now notice this one's a little bit different than the last examples that I did because I've actually found my y values, 2 of them, which means when I plug them back in, I'm solving for x. So let's take x equals 4 plus y and replace y with 0. So x equals 4. So x is 4, y is 0. Then let's do the other one. X equals 4 plus y, let's choose negative 4. So 4 plus negative 4 is 0. So when x is 0, y is negative 4. So those are my two solutions. And again, after I was done, then I would go ahead and graph them and see that those are in fact my two solutions. I wanted to throw in one example where we actually don't have a line. We have, in this case, two things that we've never graphed before, which are two ellipses. And as you'll notice, they're kind of like a circle, but they're stretched out a little bit. So basically what happened is I took the equation of a circle, which is x minus h quantity squared, plus y minus k, y minus k quantity squared equals r squared, which is how we graph a circle. And instead, for my first equation, I stuck a 5 in front of that. And for my second equation, I stuck a 5 in front of the y squared. Obviously, the center of each is at 0, 0. So these are called ellipses. You're not going to be asked to graph an ellipse, but again, you can use Desmos to help you. And what I want to do is I want to find my equations, but again, it's important to note that these can cross up to 4 times because they're 2 ellipses, and so, in this case, we actually do get 4 solutions. So let's take a look at how we might go about doing the math. This equation can turn into x squared equals 24 minus 5y squared by subtracting 5y squared from each side. I am then going to take my first equation, write 5, and instead of x squared, I'm going to put 24 minus 5y squared. And then plus y squared equals 24. So 5 times 24 is 120 minus 25y squared by distribution. Recopy everything else. 24 minus 120 is going to give me 96, and in fact it will be negative 96. And on this side, these guys combine to get negative 24y squared. Divide each side by negative 24 to get that y squared equals positive 4. Take the square root of each side to get y equals plus or minus 2. So y equals plus or minus 2 gives me my y solutions. Now I need to work to find my x solutions. So I'm going to choose, just because I already have it nice and isolated, that x squared is equal to 24 minus 5 times 2 squared, and continue to solve this one. So I get x squared equals 24 minus 2 squared is 4. So 5 times 4 is 20. So I get x squared equals 24 minus 20, which is 4. So x equals plus or minus 2. Now keep in mind what that told me. When I have a y answer of positive 2, x could either be positive or negative 2. So I could have positive 2, 2, or I could have negative 2, 2. So that's 2 of my solutions. Now let's do the same for negative 2, because I've only used positive 2 so far. X squared equals 24 minus 5 times negative 2 squared. And obviously we can see this is going to work out to be the exact same thing as we had before. X squared equals 4, x equals plus or minus 2. That's still going to give me a positive 2 comma negative 2 and a negative 2 comma negative 2. So there's my 4 solutions to this system of nonlinear equations.